Okay, let's begin section 5.3, the definite interval. We've just finished Riemann sums to find area under a curve of a non-negative function. In other words, the graphs were all above the x-axis. There was not any below. Now we're getting into definite intervals, which is an expansion of Riemann sum, and it talks about in the definition here that it is a closed interval, which is the same as the Riemann sum, and we say that the number j is the definite interval of f over ab, and j is the limit of the Riemann sum, so that we have the sigma here. This is that Riemann that we did before on finding the individual rectangles and their areas and adding them up. The following condition satisfies that an epsilon is greater than delta. There is a corresponding number delta greater than epsilon greater than 0, such that the partitions of A to B with the norm of the partitions being less than epsilon, and any choice of C sub k in sequence of these values we have. And this is the definition of the Riemann sum. Here we have it. And then we say that it has to be less than C. And we did this in the calculus one, where we had the f of x minus the limit, and j is the limit. Outcome. So we can change that j to read in this fashion. Because they have it here, they'll bring it out here. So we can say this is that Riemann sum. We're talking integration, so we first have to know about the symbols. The symbol is the integral sign that looks like a very elongated small s. And then we have the parameters, the closed interval, structured in that interval. Then the function of x, this is called the integrand, and dx, the variable changes that are possible in the reconstruction or the calculation of these items. And this is the integral of f from a to b of f of x dx. So that gives you an idea. So we're first going to get familiar with the structure of the limit as the norm approaches 0 from k to 1 to n of 8c sub k dx, delta x of k, and it's to the 7th. So we understand then that we have the integral of the -2 to 7. Now remember, this part here is the number of partitions. Since we're doing Riemann, we know they're infinite number. So we can now put the integral sign and put the -2 to 7, the lower, and then this is the upper. So lower to upper, and we're going to put 8. C of k is our x to the 7th, and delta x becomes dx in our functional notation. Now we have this next one, and we have two terms on this one. And notice they just put the k underneath to recognize that each one is a distinct term. And so here we go. We have the limit as the norm approaches 0 of the sum of k to 1 to n, number of partitions. For this value, dx of k parameter. So we're going to do our integral. We're going to place our parameter lower to upper of c of k is to the third minus 6 of c of k, which is x, and of course our dx. With a trigonomic function, and again we're adding all the partitions and we're changing it to an integral. And the integral here is going to be from pi 6 to pi halves, lower to upper, and it doesn't always have to be in that format. It's just referred to as the lower to the upper. And our term is cosecant x. Now here are the rules, and these rules are cited in the book and when they're solving some examples for you so that you can refer to them. And we're talking about order of integration. We notice that it is the opposite of A to B, because we've, instead of it being A to B, which is the normal lower to upper, they wrote it as B to A. Therefore, the integration can be swapped to any position with a negative sign, and that's called order of integration. Zero width interval is when we have the same value. We have A to A. So it is a vertical line. So there's no area to be measured. The constant, we always insert the constant outside of the integral if it gets work. And the constant is just a multiple. Sum and difference is to separate the terms for ease. Of course, we have the additivity, which means that we can start A to C plus C to B is the same as A to B if there are no differences in the order. And that's the addition. And that's where we're going to start right now. We have two functions that are related. We have the integral of 2 to 4 of f of x value, a limit, a j of 6. We have 2 to 7, which of f of x dx is, and here's our j, negative 3. And then we have a 2 to 7 of g of x dx equals. So we're going to apply those in this consideration. Well, this guy right here is 4 to 4. Our A and B is 4 to 4. So looking at our rule, that's our zero width. So the outcome is 0. We have a vertical line. Now this one says 7 to 2. Now the reverse, instead of it being 2 to 7, it is changed to 7 and 2. Therefore, it is the order of integration. Of the one given. In other words, so it's going to be the opposite of 2 to 7 of g of x. So, and remember that's a negative. Those two are going to be equal. And so So in this case, we're using this rule right here. And for us, it was a 4. This one has a multiplier. Our multiplicity, I think it was. Let me look at my rules so I can quote them easily. Constant multiple is how they called it. So what we have here is 6 multiplied 2 to 7 of g of x dx. Here we have 4 to 7. And we notice our preference, we have 2 to 4 and 2 to 7. So we're going to do the subtraction, or I should start with that one. Have the 2 to 7 of f of x minus the 2 to 4 dx, and that should give us the 4. We're removing this portion from that. This should give us 7. All right. So we recall that our negative 3 minus the 6. So we'll get a negative 9. On this one here, we have the subtraction that we could extend from it, but we see that we have each of the components with the 2 to the 6. Right, so looking back at our chart, we have this guy 2 to 7 and this guy 2 to 7, and they started with the g. So the g was the positive 4 subtracting the negative 3. So we're going to end up with a positive 7 as to the area under these curves. Now this is a compilation of several things. Have 3 times the integral 2 to 7 of g of x minus the integral 2 to 7 of f of x. Now we'll drop in the values that we know. G is the 4 minus, and the f of x is the negative 3. So that would give us 12 and 3, 15. Excuse me. So now we're stating definitively that the area under the curve of y equals f of x over a closed interval is the integral form of a to b because of that relationship to Riemann sum. Here is one that shows you about the positive side and what an absolute value is. We notice that the slope is negative, positive 1 going up. Five, which is right here, to 1. We would know we have a triangle of a 5 and a 5. So the area of that first triangle is 1/2 5 times 5. And the area of the smaller one is 1/2 of 1 times 1. Right? Well, this would give us 25 halves. And this would give us, we would have 26 halves, which is an area of 13, wouldn't it? And if we counted the squares, we could get that as well. But we want to do it by integration. So we know that we want the integral and of this guy, because we have x, right? And we can either put a negative x on this, or we can flip our whichever way we want to go. So this is one of those preferences where we, well, if I did this part, I would have, what I have, 0 to negative 5 of x dx plus 0 to 1. Work, shouldn't it? So in this case, we're talking about x squared divided by 2 for 0 to negative 5. And we're talking about from 0 to 1. If I did the math on this guy, I would have 25 halves minus 0 halves plus I would have the 1/2 minus 0. So when I do the math on that, I'd have the 26 halves, 13 square units. So minus so now we're talking about doing some math. In case we have our integral, or I'm sorry, our defined to be. And we have the integral of s. So from a to 5b. So here we have 2 squared divided by 2. And we're going to simplify that to squared from a to 5b. And that would result in our 25b squared minus a squared. Numbers, and they're ascending numbers, and we would have this as this area. So we're going to use this next one to evaluate. Now, what this is a shortcut. Some classic structures. In other words, we know shortcuts, but that's again memorization. Just look at that structure. So that would be x to the third over 3 from a to b. So they wrote out the problem, which is b cubed over 3 minus a cubed over 3, so that we could see that there is a rhythm. So if I had this guy and I used that, I would have 3 cubed over 3 minus, and I would have a 0 cubed over 3. And that would give me 14/3. Now, again, you can take, never going to abandon you, or memorize some things that may or may not help you. Now, here we have a polynomial. In this polynomial, we want to find the integration from 2 to 0. Again, we have the larger n. We have the b and a. But it doesn't matter. We're going to just do it. Well, I'm going to have a 9x cubed divided by 3. Sorry about that. Minus a 7x. I'm going to simplify that to a 3x cubed. X squared over 2 minus the 7x for our values. I'm going to do the 0 first. So the 0 is going to be 3 squared divided by 2 minus 7, 0. And you're saying, Elma, I know that's 0. Well, it's important that we see what we're going to be doing here. So now I'm going to use the 2. So this is a 3 times 2 cubed plus 2 squared over 2 minus 7 times the 2. All right. We know all of these are 0. And now we're going to see what we've got here. So this is 8. This is 24. Plus, this is 4. Is 2 minus the 14. If I do the math on this, I'm going to have 22, aren't I? Given us a value that is under the curve. Okay? Everybody comfortable with that? Oh, I did bad math. It's a 12. I forgot the 2. Sorry. And now we're getting to this guy. This is a little language. Simply addressing how to read a function and use the parameters. So I'm going to have the integral 0 to b of y equals 9x. So if we do the integration, I'm going to have 9 squared over 2 for 0 and 0, because we already know what that's going to be. So I'm going to have 9b squared over 2. This is the formula for average of the interval. It's the sum of the data, the number of data in that process. So let's see what we have here. And we're given the function and a parameter. So we want 0 to 2, x squared minus 2 dx. And so we want 1 over 2 minus 0. So I'm going to have 1/2, and now I'm going to do my integration on this side. And 2x from 0 to 2. Now I'm not going to do the 0 because we already know that it would be the 2 first and then minus the 0. So I put in the 2 and I have 8. A negative 8 times 4 is 32 by 3. And that's going to give me a negative 32 over 6. Oh, sorry about that. I only did the first part, didn't I? Something a 4. So I do common denominator. 6. This is the square root. Okay. Oh, I'm going to do this one. This is an average as well. Of 0 to 15 of, and this is in t squared dt. We're going to do FOIL squared minus 20t plus 100 d. Now I'm going to do the integration. That's 0 to 15. Very large numbers, but not bad. So I need my calculator. This is going to be a 10t squared plus 100t. To the more, oh, and I forgot to put the t squared. The t squared is 120, 125? I don't know. 225 at times plus, and that's 1500. So I'm going to enter that in the calculator. $375. end up with 25. Average is 25 because it's or the average value. This is a specific. 25 is the average. Now this is that Riemann sum with equal partitions going into infinity. So we want to evaluate that guy. I don't want you already paid our dues. We can if we want to, but it just shows you that this would work on this. And we've already let's do the integration. So we have 3x squared divided 0. We're going to insert our zeros and get 0. Excuse me. And that would be 4 12 halves, which is 6, minus, and this is a cube, so it's a negative, it becomes a positive, and this is 8 thirds. Have, when I do that, I'm going to have, this is 18, and 8 thirds, and it's negative. And it didn't tell us area, so we don't have to put any units. So in this next one, we've got a little problem involving some little math case. It says, if a vehicle averages 20 miles an hour on a 120-mile trip and then returns on the same 120 miles at a rate of 30 miles, what is your average speed for the trip? And the reasons. The vehicle averages, write the integral. All right, so we want to write our integral for this guy right here. And this one is not difficult. I thought to so we have the integral. So we're taking a trip that's 120 miles, and we're averaging our miles as rate times, this is 20t, rate times time. And we did it in 3 hours. So, actually not 3 hours. What did we do it in to get it? So we did the 120 by 20 in 6. 120 miles. I turn trip at 30. So that gave us 4 hours. So they want the average for the entire trip. All right. So the entire trip took a certain number of hours, right? So, and we want this guy is 4 hours, right? Because that gave us the 4 hours. This is 6 hours. spent 7 hours. And the outcomes are in the time. Time is 0 to 4. 10 hours. Might have been a go pit. Oh, that takes care of this guy. Thank you very much for listening.